Hello, everyone. My name is Akshat, and today I will be presenting PreCalculus Chapter 1 in Functions. I'm a curriculum director in ECDe Foundation, and my primary topic is to focus students on PreCalculus. So firstly, I'd like everyone to take out a notebook so they can copy down these definitions and symbols, if any apply. The first 5 main topics we'll be discovering are natural numbers, integers, rational numbers, irrational numbers, and real numbers. I'll be going over the definition as we go through the slides, and I hope you guys have notes so you can take it down. So firstly, I'd like to give an example of natural numbers. A natural number is a positive number that does not include 0. So for example, 2 and 3 are natural numbers. And essentially, if you want to test out other natural numbers, just use addition. 2 plus 3 equals 5, 3 plus 2 equals 5, which states that 5 is a natural number. This is basic math, and this is something that you guys should know of before. So natural numbers are closed under addition and multiplication. Integers are closed under addition, subtraction, and multiplication. And rational numbers, which hold a variety of new different topics, are addition, subtraction, multiplication, and division, except for 0. I want you guys to make sure that you understand the except for 0 section right here. So now we're going to go over interval notation. And this is essential for the beginning of pre-calculus. So know that all real numbers can be shown on a coordinate line. I want you guys to note down the actual values of these symbols right here, just to the basics of it. So for pi, you just know that 3.14 and 1/2 would be 0.5, and then square root of 2 is 1.6, 1.7. Additionally, you want to know that when graphing these polar coordinates, it goes from negative infinity to positive infinity, meaning that all the numbers that are below, suppose we have a right here, and b is less than a, then b would go to the left side of a. And so essentially, if a is less than b or b is greater than a, you're going to use this symbol right here, which is less than and then greater than. So now we're going to go over inequality properties. So there are essential ones, such as a is less than b, and if b is less than a, then a has to equal b. If a is greater than b, know that if you add any type of variable here, it will hold true. So a plus c is greater than b plus c. So let's have an example here. If a equals 4 and b equals 1 and c equals 10, I want you guys to check that property. I'll give you guys some time, and then once you guys are done, I'll go over the answer. Okay, so now you know that a over a is greater than b. So now you know that a equals 4. So you can plug a as 4 and plug b as 1. So you know that 4 is greater than 1. If c is 10, 4 plus 10 has to be greater than 1 plus 10. 4 plus 10 is 14, 1 plus 10 is 11. And now we know that 14 is greater than 11, so this property is held true. Now we're going to go next. If a is greater than b, and this part right here is very essential, c is greater than 0. Make sure that this is not a greater than or equal to, this is just a greater than. Then ac is greater than bc. So now we're going to put in the same values here. I'll give you guys some time to work on it. Okay, so we're going to plug in the numbers as we did before. A is greater than b, making 4 is greater than 1, and that is true. C equals 10, that makes 10 is greater than 0, which is also true. AC is greater than BC, meaning that 4 times 10 has to be greater than 1 times 10. 4 times 10 is 40, 1 times 10 is 10. 40 is greater than 10, which makes the statement true. Now we're going on to another one. This is quite different. So if A is greater than B and C is less than 0, this key symbol right here, less than 0, then AC is less than BC. So now we're going to try with C equals negative 10. So A, we're going to plug in as 4, B is 1. 4 is greater than 1, which is true. C, negative 10 is less than 0, which is true. Now we want to do 4 times negative 10, and then BC would be 1 times negative 10. This will give you negative 40. This will give you negative 10. Which one is greater? For anyone that answered negative 10, you are correct. If you plot this on a number line or interval notation as we did before, you'll see that negative 10 is on the right side of it. So that implies that both of these properties are true. Okay, so now we're going to go over to more algebra, some stuff that you learned beforehand. So the first steps you want to do when doing 2x minus 1 is less than 4x plus 3. So the main goal right here is to isolate x. So how do you do that? So the first step you want to do here is you want to make x as one entire section over here. So instead of doing 2x minus 1, you want to add 1 to both sides. When doing so, you'll get 2x is less than 4x plus 4. Now, knowing that all these components are true, you're going to have 2x is less than 4x plus 4. So now you want to isolate x. What you want to do is you want to subtract 2x by 4x, which will give you negative 2x is less than 4. And now when you do that, you can now divide both sides by negative 2, giving you x is greater than negative 2. And you might wonder, why is it not less than negative 2? As you guys should know beforehand, when dividing or multiplying each side by a negative number, the greater than or equal sign changes relative to what it is. So when graphing x is greater than negative 2, make sure that it's not an equal sign, right? So whenever you have it in interval notation in this number line right here, that there's this open circle on negative 2, and it's going out. Right. Okay. Now we're going to find all real numbers x satisfying negative 1 less than 2x plus 3 less than or greater than 5. Okay, so you want to make sure right here you see that less than or greater than 5. Know that this part right here is in bold. It's a dark close on that one, meaning it applies. So what you want to do here is you want to break it up into various sections. As shown in the example here, you want to break negative 1 is less than 2x plus 3 as one section, and then 2x plus 3 is less than or greater than 5 as another section. The first step you want to do here for negative 1 is less than 2x plus 3 is you want to separate the plus 3 here to a negative 3 here, which will give you 2x is greater than a negative 4. Next, you want to isolate x, giving you dividing both sides by 2, giving you x is greater than negative 2. So in a number line, you want to wait until this. So you want to wait until you solve the other side right here, which would be a 2x plus 3 is less than or greater than 5. This is a simple one. Subtract 3 by both sides, giving you 2x is less than or equal to 2, and then divide both sides by 2, which will give you x is less than or equal to 1. And then once you do that, you can apply this function so that x is greater than negative 2, but less than or equal to 1. And remember the close function. This is really important for pre-calculus, is that you have this closed dot right here on 1 because it's a less than or equal to function, sorry. And then an open circle because it doesn't apply to negative 2. Okay, now we're going to go over interval notation and set notation as well. This is essential for pre-calculus. Like I've said before, you want to make sure you're aware of the equal then symbol. So they'll give you a closed interval on both sides, as I mentioned before. And look at the interval notation here. You can see there are parentheses and brackets. So brackets apply to closed intervals, while as parentheses apply to open intervals. So like half open intervals would give you, suppose it's as you can see in the third example, a circle on the B will give you a parentheses, while a dot on the A will give you a bracket. Now you want to see there's negative infinity. What does that mean? So if you get negative infinity B, and they're both parentheses, you want to first draw an open line on B and point towards the negative infinity side. As we went over before, you know that the left side of the portion is a negative infinity, while the right side is a positive infinity. So depending on what side it is on, you want to know that and graph it based on that. And now you can see in the bottom when there's a little R symbol. If you know this one, this means the range. And so the range of negative infinity and infinity would just be any number, any real number. And so that's why that little symbol is drawn there to illustrate that. Now we're going to go over some quadratic functions. So this should all be relatively common to you guys. X squared minus 4x plus 5. What you first want to do is you want to divide that. You see that negative, you see that 2 on the right side. That should be subtracted so that you know it's a 0. That's how quadratics work. You want to have them equal to 0 so you know what x is. So once you subtract both sides by 2, you get x squared minus 4x plus 3. This would be simple. Obviously, we should know that x squared minus 3x minus 1x plus 3 is the right answer, which will factor to x minus 3 times x minus 1. And using a graph, you can see there's an open notation on 1 and 3, and then you want to point them to negative infinity and positive infinity. And there's another notation here. You can see that negative infinity 1, and there's a little u there. and then there's 3 infinity. So the little u there is, they call it the union. So when both of them, when separated apart, these are the numbers that totally form that area. Another sign of this one is called the intersection, where this is essentially backwards. So it's like it's upside down u, and that's the intersection of both points, which in this case is not true because there is no intersection. Okay, now we're going to go over another one, 5 minus x, x minus 1, x minus 3. This is a little bit easier, knowing that greater than or equal to, so you want to make sure there's closed lines here, right? So you want to divide and conquer like we've done before. 5 minus x is less than or greater than 0, making x 5, and this has to be positive, right? And there's a special method of doing this. So you know that 5 minus x, if you plug it in as 5, it will end up as a positive. So you want to go positive infinity. When you do 3, it's going to end up as a negative infinity. So you continuously go that way. But when you see 1, it will end up as a positive infinity. So what you want to do is 1 and 3 will intersect, and then 5 will go on to positive infinity. And since the equality is less than or equal to 0, we want the negatives. And using interval notation, you can know that since these are closed intervals, you're going to use brackets using 1, 3, which is the domain of it. So it goes to 1 to 3. And then you know that there's a union, like we mentioned before, and this goes from 5 to positive infinity, which is all the way there. Next, we're going to do x squared minus 1, and then x times 2 minus x. This is relatively easy as well. You know that x squared minus 1 is another kind of factor that you guys should have learned before. This will give you x plus 1 times x minus 1, greater than or equal to 0. And once you finish that out, you're going to realize that there's a difference between the closed intervals and open intervals. And so when you plug in 1, you're going to find out that it is a closed interval, and it's going to go towards positive infinity. However, when you plug in 2, there's something special about this right here. So if 2 is in the y-axis, or the denominator, so you're going to have x times 2 minus x, right? And so if x equals 2, then it'll just be 2 times 0, making the denominator 0. And what does that make the function? It makes it undefined. And so knowing that, we should know that it cannot go to positive infinity. It has to stop at 2 with an open interval. And so since you're going to have that 1 to 2 bracket right here, and you can see that in your solution as well. So you want to see that closed bracket on the 1 and the open on the 2. And then for 0, right, you're gonna see an open bracket. Does anyone know why? So if you answered that it's with the denominator as well, it's correct. So you're still going to get 0 times a negative 2, 0 times a 2, sorry. And that will end up as an undefined solution. And for negative 1, it will be the same value as 1, which makes it a positive infinity. And you have to stop at 0. And based off that, you can know that since 0 and 2 end up with the open circle, that's a parentheses, negative 1 and 1 end up with closed circle that makes it a bracket. And it's all combined with the union. So now we're going to go over absolute values. So a basic, example of absolute value would be the absolute value of negative 3. Know that any solution of an absolute value has to become a positive. And so even since negative 3 is a negative, the absolute value of that would be 3. And so now we'll see an equation. Determine all values of x for which the great absolute value of x minus 2 divided by 2x plus 1 equals 3. So the first step you want to do is, especially with absolute values, you either want to have this equation take out the absolute value in total, entirely take it out, and then have it equal to 3. But then also what you can do is you can multiply this by negative 1 and multiply this by negative 1 as well, which coincidentally gets you negative 3 equals that function because of the absolute value, because it could correspond to a negative number as well. So this is basic concepts that I need you guys to understand when doing this. Make sure you guys don't just test solutions. Know that the way to find it and then find it based on that. So finishing this problem right here, you can get negative 3 equals x minus 2, 2x plus 1. And for both solutions, what you want to do is you want to multiply 2x plus 1 by 3. And that will give you x minus 2 equals, I'm looking at the right section right here. X minus 2 equals 6x plus 3. Now you want to subtract x by both sides to give you 5x plus 3 equals negative 2. Subtract 3 on both sides to isolate that x variable. 5x equals negative 5, divide 5, and x will equal negative 1. On the other side, you're going to go -3 times 2x plus 1, which will make it a negative x minus x 6x minus 3, which would then give you a -3 equals a 7x minus 2, because you want to isolate it. Continuously want to isolate the x variable, and you'll end up with x equals a -1/7. Now we're going to go over a distance formula. This is really essential, especially in graphing as well. So the distance between two numbers on a coordinate line can be found by, and this is where the absolute value comes in. So suppose you have numbers of 2, 3 on a graph, and you want to find the distance between 2, 3, and 4, 5. You're going to use this absolute value function to determine the distance, and make sure that this distance can never be negative. This is very key right here. Distance can never be negative. So if you're taking a test on PreCalculus and you see the distance and you put it as a negative number, even if you're in the right direction, it will be marked off. And also you want to make sure that you can find the midway point just by multiplying by 1/2 or dividing by 2. And it does not matter which number you let be your x1 or x2, just make sure it's aligned with the graph. So let's see, find all values of x that satisfy the square root of 2x minus 3, sorry, 2x to the minus 1, and then less than 3. Know that, remember, like I said before, you can either just take out the absolute value entirely, or you can make this 3 on the other side a negative. And once you do that, it will be x is greater than -1, and then x is less than 2. Remember, do not change the direction of the inequality symbol, right? So you can see that x is, so when doing that, it's essentially really simple. You get x is greater than -1. So you go in the positive infinity direction, but x is less than 2, which you go in the negative infinity direction, and then meet up. And remember, it's open notation because there's no equality signal. I hope you guys learned more about absolute values and functions in itself, and more importantly, interval notation, which, as you can see, as we go back here, interval notation and set notation, and the graphic representation as well. This was the main key, of course, of the main absolute kind of purpose of this lesson here. You guys learn more about this, and I will see you next time with another video. Thank you. Bye.